All right, so this is the last 15 questions of this ACT. Which ACT is this anyway? It is the April 2018 AO9 ACT. You should be able to find that online if you'd like. So here's number 46 through 60. Now remember, ACT goes easy to hard. So we expect these questions to be some of the hardest questions. And it does get pretty hard or advanced towards the end. So let's see. 46. As x continuously increases in value without bounds, the value of that most closely approach what? Okay. So yeah, getting right into it advanced. So x is getting bigger and bigger. So think about what would happen as x gets really, really big. Like this is saying as x goes to infinity. Really, this is a calc problem. This is saying what is the limit as x goes to infinity of x over x plus 3. But if you've never done that, that's okay. All we're thinking about here is what happens when x gets really, really big. And you can just plug in, like, think about a really, really big number for x. If you even wanted to do it in your calculator, you could. But you don't need to. You just want to say, because if x is really, really big, basically, like, what is this really, really big number? I mean, I guess the whole idea is if you take a really, really, really huge number down here and you add 3 to it, that 3 barely affects it, right? That 3 basically is nothing compared to that massive, massive number that x is going towards. And so basically what's happening here in this equation is once x gets really, really big, that 3 does not matter at all. So once x gets really big, this equation is really just x over x. And so what is x divided by x? I mean, it's no tricks. Those just cancel out, and that gets 1. So what that's showing then is as x gets really, really big, this thing is getting closer and closer to 1. Of course, it'll never be 1 because the denominator will always be a tiny bit bigger than the top. But as that x gets really big, that tiny bit bigger is going to matter so little. So it really will just be close to 1. So 47. Yulon will use a bag of 30 solid colored marbles for a game in which each player randomly draws marbles from the bag. The number of marbles from each color is shown below. Yulon will randomly draw 2 marbles from the bag, one after the other, without replacing the marble. What is the probability that he'll draw a black marble first and a green marble second? Ooh, okay. So when I see things like this, I like to kind of just draw blanks for what events are happening. How many events are happening? 2. He's drawing 2 marbles. And so then with each event, you need to think about the probabilities of those events. So the first event, what's the probability of the first thing happening? Well, we want him to draw a black marble out of all of the marbles. So we'd say, what's the probability of that actually happening? Well, there's 6 black marbles out of how many total marbles are there? You add them up, or they tell you that there's 30. So what's the probability of success there? 6 out of the 30 marbles. But then the second marble, this is where it matters that it's without replacement, because now when he's drawing the second marble, he's already taken the first marble out. So how many marbles are there now? There's 29 marbles. And how many green ones are there? Well, he didn't take the green one first because he took a black one. So there's still 2 green marbles. It's just that now he's choosing the 2 green marbles out of the 29 marbles. And so now when you want a bunch of events to happen, you just can multiply their probabilities to find the probability of both events happening. So you just multiply these together. So you can use a calculator. I don't usually use calculators. So I'm going to cancel out that 6. So that's 5 times 29. So that's 30 times 5 minus 5. So that's 145. So it's 2 out of 145. Very low probability. Why does that make sense that it's very low probability? Well, 2 out of 29. To draw the green marble, that's a low probability. So the answer is B. All right, 48. The expression is undefined when. So that's like domain. What makes something undefined? If it's a fraction especially, it's when the denominator, b minus 2c, equals 0. So what are they asking us for? What is b? Well, we can just solve for b. When b equals 2c, I guess we should say not equals because that's when it's undefined. So when b is equal to 2c, the thing is undefined. Is that an option? Yeah, okay. And you see why, because when you plug that in, it doesn't matter what's happening at the top. If b equals 2c, you're going to get 0 on the bottom. All right, 49. What number is halfway between 2/5 and 8/7? Well, normally I don't use calculators, but this is just a straight calculator problem. Notice that it's really nice if you have numworks. I guess a lot of calculators do this nowadays, but because they'll leave the answer in a fraction for you, especially if you put it in as fractions. So how do you find the middle of two numbers? You just average them. So we'll just add those together and divide by 2. And they tell us 27 over 35. Is that an answer? Yeah. So we're just adding them together, divide by 2. You can do that no calc, but you have a calculator. So we're just going to use the calculator. All right, 50. A function is defined as that. What two real numbers satisfy x equals 1? F of x equals 1. Okay, so we're setting the whole function equal to 1. And now you might be confused for a second, or you might just jump straight to logarithms. But I don't even think we need to necessarily, because think about if you take 3 to some power and you get 1, what does that some power have to be? Well, 3 to what power gets you 1? That only happens once. It doesn't even matter what the base is. That has to be 0. Anything to the 0 gets you 1. So that's saying that x squared minus x minus 2 needs to be 0, right? So then you just got to solve that equation. So you just factor. Hopefully you can factor quickly. X minus 2, x plus 1, 2, and negative 1. And since there's no options where there's only one answer, you can be pretty solid that those two are going to work. All right, cool. 51. The ellipse shown in standard form below has that equation. Which of the following ordered pairs are the foci? Whoa. How do you calculate the foci of ellipse? Yeah, that's tough. I thought I'd just have to say, well, we've got the center, but they show us everything. The center is going to be 3, 5, because it's the opposite value of these. But we see that right here. They even label those. And then the y radius is 5, because it's the square root of that. That's why it's going up 5 and down 5. The y radius is 3. That's why it's going left 3 and right 3. But they're talking about the foci. So we got to think back, way back to conic sections. So how do you find the foci of ellipse? Well, you got to find the c value. And what is the c value? I just always remember that as you got ellipses and you got parabolas. Or you got ellipses and you got hyperbolas. So for the ellipse, to find the c value, you've got to subtract them. And of course, you've got to do the bigger one minus the smaller one. Otherwise, it would be negative. But you can't have a negative being something squared. So you got to subtract. You do the bigger minus the smallest. ry squared minus rx squared. If it was a hyperbola, it would be ry squared plus rx squared. And so what do we get then? Well, this is c squared, ry squared. You see, those are just down there. That's kind of convenient that we want them squared in the equation. So 25 minus 9. So c squared equals 16. So c, I guess technically is plus or minus 4. And what that's telling us is that from the center, we go 4 in one direction, 4 in the other direction, and those are going to be the foci. Notice you have to go up and down. You have to go on the longest one. Otherwise, it would end up outside the circle. Then you just look at what those points would be. Let's see, that's up 4 from 5. So that's at 9. So it's 3, 9 and 3, 1. And that's another big difference. I mean, the SAT would never ask you that. The SAT doesn't ask about the foci. So that's why I always say the ACT, the questions are very straightforward. I mean, this was a very straightforward question. But if you don't know how to find the foci, you're done. Whereas on the SAT, the questions are hard to understand, but pretty easy to do once you get it, once you see what they're asking. All right, 52. A basket contains 10 solid colored balls, 2 blue, 3 red, 5 green. That is 10. Each ball has a single number printed on it. The blue balls are numbered 1 through 2. Red balls are numbered 1 through 3. The green balls are numbered 1 through 5. All right. A ball will be drawn at random from the basket. What is the probability that the ball that is drawn will be red or have a 3 printed on it? All right, so we could think about formulas, but I would rather not. I would just think about out of the 10 balls that we have, so it's out of 10, which all the answers are, which ones are red or have a 3 printed on them? Well, 3 of the balls are red. So let's start with 3 of the balls that are red. And then how many balls have a 3 printed on them? Well, actually, just 2 of them do, because there's no blue number 3, because there's only 2 of them. But there's a red number 3, and there's a green number 3. But here's the thing about OR, is we already counted the red number 3 in this, right? Because we just said there's a total of 3 balls. So actually, how many more balls have a 3 on them that we haven't counted already? Just 1. Just the green one with a 3 on it. So it's going to end up being 4 out of 10. Because there's 3 red balls, and then there's 1 other ball that has a 3 on it that we haven't counted yet. And so if you think about the formulas, the formula people say for this is that if you're trying to do OR, you're going to take the total number of green balls, you're going to take the total number of balls with a 3 on them, and then you're going to subtract where both of that happens, the red ball with the 3 on it. And that only happens once. And that's out of 10. And you see, using that formula idea, you still get 4 out of 10. All right, 53. And the figure below, what is the area? All right, so things you might be tempted to do. You might be tempted to say, 12, 13. So it's a 5, 12, 13. But they don't tell us that this is a right triangle. And if it would be a right triangle, it'd be a 30, 60, 90. And 30, 60, 90s don't have that side relationship. So that actually tells us for sure that it's not a 30, 60, 90 triangle. So there's a couple things you can do. There's actually a formula that just gives you the area. Let me see if I remember it. I don't think I do. I think it's 1/2 AB sine of C. So let's take a guess. If that is that formula, then this is the answer. But let's see. If we don't know that formula, what would you do? Well, you'd want to find the height. Because what's the normal triangle area formula? Is base times height times 1/2. 1/2 base times height. So we know the base is 13. So we'll do 1/2 times 13. We just got to find that height. So how are we going to find the height? Well, we have this angle, so we're going to have to use some trig. So what trig are we going to have to use? Well, we want the opposite side. We know the hypotenuse. We don't actually know the adjacent, right? Because the whole thing is 13. We don't exactly know how long that part is. So we're going to have to use the hypotenuse and the opposite side. So what's hypotenuse and opposite? Well, that's sine. So we'll say that the sine of 30 degrees is the opposite over hypotenuse, h over 12. And now what's sine of 30? You should probably know that. If you don't, you can just type it in your calculator. But if you're doing it in your calculator, make sure your calculator is in degrees instead of radians, because a lot of them default to radians. But you should just know the sine of 30 degrees is 1/2. So then you have that 1/2 equals the height over 12. So multiply both sides by 12. And the height is 6. And that'll get us our answer. 1/2 times 13 times 6. Cancel. 13 times 3. So the answer is 39. Beautiful. So I'm wondering if that's what we got over here. No. So is this 1/2 not there then? It's just AB times sine of 30? I think that's what the formula is, because the sine of 30 is the 1/2. All right, cool. But yeah, the answer is definitely 39. Should we check that real quick? Oh, no. It'll take too long to go down and check that. I'm confident about that. All right, 54. There are 66 calories and 15 grams of grated Parmesan cheese, and 59% of those calories are from fat. All right. When measuring Parmesan cheese, 5 grams is equal to 1 tablespoon. Okay. Which of the following is closest to the number of calories per fat per tablespoon of Parmesan cheese? Okay. So what do we want? I would just look at the units of what we want and try to build that units. So which of the following is closest to number of calories from fat? So I'll say calories from fat per tablespoon. All right. So first, let's look at how many in 15 grams. So how many calories per fat are in 15 grams? Is that what we should start with? I guess so. So let's do 66 times 0.59. We have the calculator for that. 66 times 0.59. So we have 38.94 calories per fat. 38.94 calories per fat per 15 grams. That's what we have right now, right? That's what they tell us. 384 calories per fat per 15 grams. And what do we want? We want per tablespoons. But then next they tell us that 5 grams is 1 tablespoon. So we are able to cancel out this grams, 5 grams per tablespoon. And so see now how we do tablespoon. Now the grams are canceling and we have calories of fat per tablespoon. And so I would look at this. Do we even need the calculator? Because it's about 38.94 divided by 3. That's definitely going to be 13. Not exactly probably, but close enough. Because I'm just looking 30 divided by 3 is like 10. So this is going to be a bit more than that. Yeah, roughly 9 more than that. So that divided by 3 is, 12.98. Definitely 13. All right, we're making good time. It's taking us about twice as long as it would normally, but that's because I'm explaining them so much. I could do these faster. And you could too, because you won't be explaining them. All right, so we got the diagram. The area of the square is 1/4 of the area of the whole thing. I can see that. What percent of the area does ACDE of the big square does that portion represent? Whoa, that's weird. I mean, we can definitely just look at it. Like, I feel like we don't need to prove anything. We got the right angle there. We see what's going on. This is 1/4 of that square. But this square is 1/4 of the other one. So notice here all these ofs that we have the whole area. The little square is 1/4 of that area. But then this is 1/4 of that. So altogether, it's 1/16 of that. And then they just want us to say what is 1/16 as a decimal. It's 0.0625. Oh, and they're in their mean here because they're talking about it as a percent. So you got to convert this back into a percent. So it's not 0.0625%. See how that doesn't make any sense anyway? That's like nothing. That's super small. It's 6%. I guess it's not that much clearer that that's what it is. But you just know percent, so you got to multiply it back into 100. You got to move the decimal place over twice. So 0.0625 is representing 6%. Again, I don't know why percents exist. We really should get rid of them. You just use the decimal. That's normal. All right, 56. In the data set of 10 distinct values, the single largest value is replaced with a much greater value to form a new data set. Which of the following statements must be true about the mean and the median compared to them? So let's think about that. Let's kind of build an example. So we've got 10 values. At least it says that. We can change it to having like 4 values. So let's say this is the original data set. And then we're going to change this 5. We're going to get rid of that and make it a lot bigger. Let's say we're going to change it and make it 500. And let's think about the mean and the median. So the median, what was the median before? Well, remember the median just means the middle number. So you're just going to look here in the middle and say, what is the middle of 2 and 3? It's 2.5. And notice how if we change that 5 to 500, that does nothing to the median. Because that 5 was never involved in the median in the first place. So when we change that highest value, that's not going to affect the median at all. But see how it'll definitely affect the average. If we think about the average before, add all those up and divide by 4, you get like 11 over 4, which is like 2.5-ish. But now with the 500, if you add all those up and divide by 4, that's like massive now, right? 500. It's like 500. Basically, it's just 500 divided by 4. It's like 125-ish. So yeah, that is a massive change on the mean. So the median will stay the same. The mean will increase. F is looking pretty good. And that's just something generally you can know. That's one of the big benefits of using the median, is that the median, you call it resistant to outliers, is that if you add a big outlier, that's not going to affect the median that much. but it will affect the mean. All right, this one. I'm surprised this one is here, to be honest. So they're talking about matrix products. So all of these is matrix times a matrix. So you've got to multiply matrices. You don't have to multiply matrices on the ACT. Here, on the SAT, on the ACT, you do. So first off, we see these two distinct differences between sizes of matrix. So when you talk about multiplying matrices, the sizes definitely matter. So first off, when you name the sizes, it's always row column. I always remember rat cow. It's rat cow, it's pretty easy to remember, right? So it's always row column, rat cow. So row first. How many rows, looking at E, how many rows does it have? It has 2 rows. How many columns does it have? It has 1 column. So that is a 2x1 matrix. Whereas this one, I mean, it's a square, so it's easy to name. That's a 2x2 matrix. And the deal with multiplying matrices is that when you multiply matrices, these 2 numbers right here, the 2 middle numbers, have to be the same. So right here where you see that they're not the same, you just can't multiply those matrices. So like D and E, you can cross those out right away because you're not even able to multiply matrices that are that size. Now up here you can, because what size is this? There's 1 row by 2 columns, and this is 2 rows by 2 columns. So here, the numbers are the same in the middle, which means you can multiply them. And then how do you know how big the answer is? Well, the size of the answer is the 2 outside numbers. So we know that if we multiply these two, the answer is going to be a 2x2. So I do like to write that out and think that's what our answer is going to look like. And let's go ahead and just keep looking at answer choice A and say, how do we even multiply these matrices now? Well, what we do is we look at our answer. We look at the spots in the answer. That's why I like to draw out the spots. And I'd say like this spot right here, what position is it? What row and what column is it is? Always RC, always rat cow, row column. So if that's in the first row and the first column. And so how we're going to multiply this is we're going to look at the first row of the first one and the first column of the second one. And we're going to multiply these corresponding numbers. And see, that's why that size matters. Those middle numbers have to be the same because you have to have numbers that match up there. So you're going to do 5 times 1 and then add 3 times 10. So you'd end up with 35 there. And then the next position, you just do the same exact thing, except this one is in the first row and the second column. So you're still going to look at the first row. I mean, there's only 1 row. But then you're going to look at the second column here. So this one, but didn't do the same idea. This one is going to be 5 times 2 plus 3 times 25, which ends you up with 85. So that's the idea with matrix multiplication. I don't think they make you do it too much. I think this is the first time I've seen it. But as we see, they can do it sometimes. So let's see what they even want. So Valley High School and Mountain High School have decided that selected students will attend a daytime theatrical performance that costs $5 for each teacher and $3 for each student. 1 teacher and 10 students from Valley High School will attend, and 2 teachers and 25 students from Mountain High School will attend. Which of the following matrix products shows you that? So I would try to write out the equation that we actually want here and then see which matrix that corresponds to. So I would say it's $5 per teacher. So let's go with $5. And then we have 1 teacher from the one school. So we want 5 times 1. But then the other school has 2 teachers. So we want 5 times 2. And then what is the other thing we want? The student tickets. The students are $3, so we want $3 times the number of students plus $3 times the other number of students. So now I would look at each matrix that we have, what corresponds to those two equations. And I'm liking C because I'm seeing that here we're going to do... do I not like C here, actually? Maybe I don't like C. Because what are we going to have here? We're going to have 5 times 1 and 3 times 2. That's nothing we have over here. So maybe I don't like C. Let's look at B. We have 5 times 1 and then 3 times 25. I like that. 5 times 1 and 3 times... this is supposed to be a times. 3 times 25. And then what's the other one? 5 times 25. 3 times 10. Oh, I don't like that. Is this just what we already calculated? It's just A. Let's see. We've got 5 times 1 and 5 times 2 and 3 times 10 and 3 times 25. That's exactly what we want. It's just A. So that was tough. That's kind of a rarity of the ACT question. First off, just multiplying matrices, I think, is a rarity. And I don't know if there's any good way to just immediately see what it's going to be. I mean, I guess you got the 5, and then you see how you're going to do this 5. Oh, well, you end up doing the 5 times those. And then you end up doing the 3 times those. So I guess you could try to see that. I don't know. I would probably do most of that out. That would probably take me a while in real life to do. So is this one. This one seems interesting. Carrie is inventing a new notation for math. Whenever you start doing that, you know you're doing bad stuff. She has decided to use n down to denote the sum of the first n positive integers. It's not bad. We already have stuff for that, though. For example, 5 down means that. Carrie has written 3 statements that she's investigating as possible properties of n down. Which of these statements is true for all positive integers? Okay, positive. That makes sense that this has to be positive. It says that in the question, too. Okay, so n down plus n plus 1 is the same as n plus 1 down. All right, that makes sense because this is basically like factorial for addition. So this is saying n plus n minus 1, just dot, dot, dot all the way down. But this is adding on the 1 higher than n. So then what is that? That's n plus 1 all the way down. So I like 1. 1 seems to work. That reminds me of the factorial property where n factorial times n plus 1 is equal to n plus 1 factorial. As normally you go the other way for that. But this is just the same idea for addition. So what about number 2? Oh, that's tempting. But I don't think that's true. Because this is... yeah. Because we have like n plus whatever all the way down. Plus n plus whatever all the way down. So the problem is this is like 2 times n. But then this would be like 2 times n minus 1. And see, that's just not, this is supposed to be 2n times 2n minus 1. Like subtract it from the double n. But see here, this is like even if you distribute this, you see why it's wrong. Because you'd be subtracting 2 from the double n, doing it that way. So 2 is not correct. It'd be correct if you had this, that the 2 was multiplying by that. But how they wrote it is not correct. So 2 is not correct. So what can we cross out? We liked 1, so we've got to have 1 in our answer. Well, that is a predicament. Is 1 not true? We'll go back to 1. But 2 is definitely not true. 2 is definitely not true. Because you're not going to get, it's like you're only going to get the even numbers, whereas this would have all the odd numbers included. 2 is definitely not true. 2 cannot be true. Oh, it could just be 1 only. Never mind. Oh my gosh, my logic. So 3, yeah, it's probably just F then. In fact, it's got to just be F by what we said. So let's see about 3 then. N squared versus that squared. Huh. So if it's n squared, so that's like, I guess we could do real world examples too. So if like, we'll just do if n is 2. Yeah, so if n is 2, that means we're doing 4 of that, which means we're doing 4 plus 3 plus 2 plus 1. If n is 2 here, that means we're doing 2 plus 1, but then we're squaring it. And that might be the same here, maybe not, but it's definitely not always going to be the same. And no, it's not even the same here, because you get 10 for this. So yeah, 3 is definitely not true, which means, which we already knew since 2 wasn't true, F had to be true. F is the answer. All right, these are some fun problems. So 59, Ray wants to make an open box as shown below using a square piece of cardboard. He intends to cut a 2-inch... Right, so it just says everything here. The resulting box will have a volume of 72 inches. What are the dimensions in inches of the original piece of cardboard? Oh, wow, that's interesting. So we're looking for like this. This is our X that we want to find. But let's look at this box and let's say what's the volume of this box. So it's 72. So I mean, volume of a box, length times width times height. So we see the height is going to be 2. And then it's going to be a square, right? 2-inch square. It's using a square piece of cardboard. Yeah, so he's starting with a square. So the dimensions of this box doesn't show it very well, but these are the same. The length and width are the same. So I'll just call that y. So this is y times y, or y squared. So then we're just going to solve for y. We can solve for that length. That's pretty easy. You get 36 equals y squared and square root both sides. And since it's a length, you don't need to include the negative. So we know then that the dimensions of the base have to be 6 and 6. So then just quickly think about what does that actually mean the dimensions of the original box are. So you got to add 2, and don't forget that you got to add 2 to both sides because we cut it off from both sides. So the original is a 10 by 10. That was a fun problem. And lastly, just over 30 minutes for the whole thing. That's not bad. Which of the following quadratic equations has the complex number that as a solution? So what do you want to do? You could start with these and solve these. But I think I would prefer to just write the equation, which is not normally what I'd like to do, but I would like to do here. So what is the equation? Well, if that's a solution, remember, so if 2 is a solution, that means that x minus 2 is a factor. So if 1 plus root negative 1 is a solution, that means that 1 minus 1 plus root negative 1 is a solution. And then now you have to just know about complex numbers, that if you have, or just think about the quadratic formula. Maybe you can just work backwards with the quadratic formula here. We'll think about that afterwards. That's probably quicker. But if you have like 1 plus root negative 1 as an answer, you're also going to have 1 minus root negative 1 as an answer, because that's the plus or minus from the quadratic formula. So if we do that, we're going to have x minus 1 minus root negative 1. So that's definitely the equation. So now if you're doing it this way, you would just want to FOIL and see what you'd get. So you'd have x times x, that's x squared. You'd have x times 1 minus root negative 1. Actually, times minus that. So maybe, actually, yeah, before we do that, we should distribute that negative so we're less likely to make a mistake. So we've got x minus 1 minus root negative 1 and x minus 1 plus root negative 1. So now we're less likely to make a mistake. So let's go. We got x squared, x times negative 1, negative x times root negative 1 plus x root negative 1. And then negative 1 times x, negative 1 times negative 1, negative 1 times root negative 1. Okay. And then we've got root negative 1 times x. So minus x root negative 1. Negative root negative 1 times negative 1. So that's plus root negative 1. And then root negative 1 times root negative 1. Well, I mean, what's the square root of 2 times the square root of 2? The square roots just go away and it's 2. So what's the square root of negative 1 times the square root of negative 1? Well, it's just negative 1. But it's negative square root of negative 1 times positive square root of negative 1. So that should be minus negative 1. And now we'll combine like terms. And the beauty of this is all of the root negative 1s should go away. Because you don't want root negative 1s, right? That's like not even real. So those are going to cancel out. What else? Positive root negative 1, negative root negative 1. They're going to cancel out. And then we'll combine like terms. So we just have this 1x squared, negative x minus x, negative 2x. And I like to cross out as I go so I make sure I don't miss anything, like this positive 1 right here. And that, negative times negative, positive 1 right there. So that should be the answer. Let me think. I want to think building backwards from the quadratic formula. So what is the quadratic formula? It's negative b plus or minus the square root of b squared minus 4ac over 2a. So when I know that that's the quadratic formula, and I look at these answers. So first off, all of the answer choices, a is 1, right? Because that's just the coefficient that's here. So I know that this is a 1 down here. And then I'd say to get that b value, to get this positive 1, if I know that I'm dividing by 2, I'm going negative b over 2, and that's getting me a positive 1. So what does b have to be? B is going to have to be a negative 2, right? If you just solve for b there. So I know that a is 1, and I know that b is negative 2, and actually that's the only one that b is negative 2 in. So that's a beautiful way to solve that problem, is think about the quadratic formula. And then I guess you could just confirm for yourself and calculate what the c would need to be, because this b squared minus 4ac, everything inside the square root is ending up as negative 1. And if we know the a and we know the b, so b squared is 4 minus 4a is 1. C, and we need that to be a negative 1. Whoa, hang on, that didn't work out. Right, because we don't want it to be a negative 1, because that's over 2a in there. Ooh. So that's tougher to confirm, but notice that we're really looking at like that. We're saying that that is the square root of negative 1. So it's like really we have to put that 2a back into the fraction. So make that like, or into the square root. So make that 4a squared. So this wouldn't even be worth confirming your answer, because we've already gotten the answer from this method by just looking at the b, just looking at the negative b part in the front. So this is just confirming our answer, which seems to be more trouble than it's worth. But from here, we can do it. We can say that this is 4 minus 4c over 4a squared. A is still 1, so that's just over 4. And that has to get us negative 1. And there we go, because now we're dividing by 4, so we cancel both of those 4s. 1 minus c is negative 1. Maybe add the c, add the 1, and we get that c equals positive 2, which is indeed what that is. So that's pretty cool. That was a little just extra way to solve it. Second way we solved that was definitely better. But that's the ACT. So those were not as hard as I thought they'd be at the end. I thought that would be the hardest. But yeah, matrix multiplication, you're not going to find that on the SAT. Which of these would you never find on the SAT? You might find that on the SAT. You wouldn't find this on the SAT. Nah, you would find that on the SAT. You'd find a lot of these. What would you never find? You'd never find the foci on the SAT. I don't think you would find this on the SAT either, because they don't do logs. I guess all the other ones you probably would. But yeah, they'd probably be more confusing on the SAT than they would here. But that was fun. We'll be back later with another ACT.